easy questions, problems. First one, 3x plus 6y equivalent to 1, 2, 3, 4. X comma y are natural numbers. X comma y are natural numbers. How many values x comma y will take? 3x plus 6y equivalent to 1, 2, 3, 4. X, y are natural numbers. How many values x will take? Now see the solution. It's a very easy question. 12 plus 15 equivalent to 27. 12 plus 15 equivalent to 27. 12 is divisible by 3. 15 is divisible by 3. 27 is also divisible by 3. Left hand side 12 is divisible by 3. 15 is divisible by 3. Right hand side 27 is also divisible by 3. So this will be 3x plus 6y equivalent to 1, 2, 3, 4. Now if you observe carefully, 3x is divisible by 3. 3x is divisible by 3. 6y also is divisible by 3. 6 is nothing but 3 into 2. 1, 2, 3, 4. What is the divisibility rule of 3? Sum of the digits should be divisible by 3. Sum of the digits should be divisible by 3. 1, 2, 3, 4. 4 plus 3, 7. 7 plus 2, 9. 9 plus 1, 10. 10 is not divisible by 3. So answer for this question is no solution. Answer for this question is no solution. Very good question. 3x plus 6y equivalent to 1, 2, 3, 4. 3x plus 6y equivalent to 1, 2, 3, 4. 3x is divisible by 3. 6y is divisible by 3. 1, 2, 3, 4. 1, 2, 3, 4 should be divisible by 3. Sum of the digits should be divisible by 3. Sum of the digits should be divisible by 3. 1, 2, 3, 4 is not divisible by 3. So answer is no solution. Answer is no solution. First one. Second question. In how many ways can a person gives 500 rupees using 20 notes? Each of 5 rupees, 20 rupees and 50 rupees. In how many ways can a person gives 500 rupees using 20 notes, each of 5 rupees, 20 rupees and 50 rupees? In how many ways can a person gives 500 rupees using 20 notes, each of 5 rupees, 20 rupees and 50 rupees? Question solution. So there are 5 rupees, 20 rupees and 50 rupees. Total number of 5 rupees I will use is X. Total number of 20 rupees I will use is Y. Total number of 50 rupees I will use is Z. So the equation will become 5x plus 20y plus 50z. Total it should be nothing but 500. And the total number of notes I should use is x plus y plus z is 20. So if I cancel out the coefficient of phi in the first equation, this will become x. Next will become 4y. Next will become 10z. Next will become 100. So if I subtract it, it is 3y. It is 9z equivalent to 80. Exactly to solve this question only I solved the first question. 3y plus 9z is nothing but 80. 3y is divisible by 3. 9z is divisible by 3. 80 should be divisible by 3. 80 is not divisible by 3. So answer for this question is no solution. Answer for this question is no solution. You cannot give if 3x square plus 4x plus 5 equivalent to 0 and ax square plus 7x plus c equivalent to 0 has at least one common root. Find a plus c. Another variety of question. If 3x square plus 4x plus 5 equivalent to 0 and ax square plus 7x plus c equivalent to 0 has at least one common root. Find a plus c. If 3x square plus 4x plus 5 is 0 and ax square plus 7x plus c is 0 has at least one common root. First the equation is 3x square plus 4x plus 5 equivalent to 0. That means discriminant of the quadratic expression is b square minus 4ac. b is 4 value. 4 square minus 4 into 3 into 5. It is nothing but 16 minus 16, which is minus 44. Minus 44 is less than 0. That means the equation is roots are imaginary. Roots are imaginary. Next point. Imaginary roots always happens in pairs. Imaginary roots always happens in pairs. So if one equation has got roots imaginary, if this equation has got roots imaginary, that means there will be two roots will be common. Roots will happen in pairs. Two roots will be in common. Two roots will be in common. It cannot have one root common because if the roots are imaginary, roots will always happen in pairs. Note a1x square plus b1x plus c1 equivalent to 0. a2x square plus b2x plus c2 equivalent to 0. If two equations are there and both the roots are common, and if two equations are there, if both the roots are common, what will be the condition? Condition will be a1 by a2 equivalent to b1 by b2 equivalent to c1 by c2. Very, very important note. Good number of questions came from this very, very important point. What is the point? If there are two quadratic equations, a1x square plus b1x plus c1 equivalent to 0 and a2x square plus b2x plus c2 equivalent to 0, if both the roots are common, condition is a1 by a2 equivalent to b1 by b2 equivalent to c1 by c2. a1 by a2 equivalent to b1 by b2 equivalent to c1 by c2. What is the quadratic equation? Quadratic equation given in the question is 3x square plus 4x plus 5 equivalent to 0. What is the next equation? ax square plus 7x plus 7 equivalent to 0. So these are nothing but 3 by a equivalent to 4 by 7 equivalent to 5 by 6. So a is nothing but 21 by 4 and c is nothing but 35 by 4. So a plus c is nothing but 36 by 4, 9. Very, very good question. Even though he gave that at least one root is common, d is less than 0. So 3x square plus 4x plus 5 equivalent to 0. D is less than 0. So D is minus 44. D is less than 0. Discriminant less than 0. That means the roots are imaginary. Imaginary roots always happens in pairs. That means two roots will be in common. Two roots, if they are common, what is the condition? a1 by a2 equivalent to, right? a1 by a2 equivalent to b1 by b2 equivalent to c1 by c2. So substitute it, you will get it. To find the nature of roots, Anurag, this for you. b square minus 4ac. This is the discriminant. b square minus 4ac. This is the discriminant. Discriminant is used to find the nature of roots. For the quadratic expression ax square plus bx plus c. To find out the nature of roots, we will use b square minus 4ac. To find the nature of roots. We will use a b square minus 4ac to find out the nature of roots for ax square plus bx plus c. There are three cases that are possible: greater than 0, less than 0 and equivalent to 0. Less than 0 means roots are imaginary. Less than 0 is roots are imaginary. B square must be a perfect square. If the d value happens to be a perfect square, it will be rational and unequal. If d is a non-perfect square, the roots will be irrational, and unequal. These for you, Anurag beta, right? If for a quadratic expression, b square minus 4ac helps us in finding the nature of the roots. We can tell whether the roots are equal, whether the roots are imaginary, or whether the roots are unequal. This is for the imaginary, this is for equal, and this is for the unequal roots. This is for the quadratic expression. This for the quadratic expression. These for the quadratic expression. These for the quadratic expression, right? Please go through the basics of quadratic expression. Anurag, I cannot keep on explaining what. Again you will ask me what is a root. Then again you will ask me, kindly go through the quadratic equations PDF. Then you can watch this class. It will be perfectly clear, right? Next one. Absolute fundamentals. I do not like to waste time. Nature of roots. What is root? Check it out in a thing. Now, a smart student might ask me a question, sir, what if it is a cubic expression? Please write down, sir. This is not something which you will find in the regular textbooks. A, B, C, D are rational. A, B, C, D are rational. Ax cube plus bx square plus cx plus d. A, B, C, D are rational. A, B, C, D are rational. Very, very important point. B square less than 2ac is the condition for it to get imaginary. Imaginary roots always happens in pairs. So I1 and its a conjugate I2. B square greater than or equivalent to 2ac. B square greater than or equivalent to 2ac is for the three roots to be real. R1, R2 and R3. Extremely important point. For a cubic equation, the condition for the roots to be imaginary. For a cubic equation, the condition for the roots to be imaginary. Condition for the roots to be imaginary. Condition for the roots to be imaginary. It is nothing but b square less than 2ac. Extremely important concept because many students know only about the quadratic expression. Condition for the roots to be imaginary. Condition for the roots to be imaginary. Condition for the roots to be imaginary. It is b square less than 2ac in a cubic equation. Please make a note of it. Very, very important point. Based upon this, there is a question. So question number, write down the question number. Question number 4. I hope this concept is clear. Good that Anurag, you have asked a question for which many students came to know about the cubic equation. 4th question. What would be the nature of roots? What would be the nature of roots? What would be the nature of roots? X cube plus 5x square plus 25x plus 125 equivalent to 0. What would be the nature of roots for x cube plus 5x square plus 25x plus 125 equivalent to 0? This is a cubic equation. This is a cubic equation. In this cubic equation, we'll check what will be the possible. B square less than 2ac. If it is b square less than 2ac, it is nothing but 5 square less than 2 into 1 into 25. So it is nothing but 25 less than 50. 25 is less than 50. That means what is the answer for this question? Roots are imaginary. You can check the nature of the roots for a cubic equation based upon this condition. You can check the nature of the roots based upon this condition. Find the number of real roots. Find the number of real roots for. This is a little advanced level question. X power 4 plus 2x cube plus 3x square plus 2x plus 1 equivalent to 0. Find the number of real roots for x power 4 plus 2x cube plus 3x square plus 2x plus 1 0. These, can I say this entire equation is nothing but x square plus x plus 1 whole square. Observe carefully. So it is nothing but a square is x square plus x whole square plus 2ab plus 2x square plus x into 1 plus 1 equivalent to 0. This is nothing but x power 4. Next is 2x cube. Next is x square. Next is 2 into x square plus x plus 1 equivalent to 0. So these is nothing but x power 4 plus 2x cube, 2x square plus x square, 3x square plus 2x plus 1 0. So these are nothing but x square plus x plus 1 whole square, x square plus x plus 1 whole square. Already we know these are nothing but these a quadratic equation, b square minus 4ac, b square minus 4ac, 1 minus 4 is minus 3, minus 3 less than 0, that means the roots are imaginary. That means the roots are imaginary. That means the roots are imaginary. I hope it is clear. Sixth, this is again an examination perspective question. Ax square plus bx plus c equivalent to 0 and 7x square plus 24x plus 25 equivalent to 0 has a common root. ABC are the sides of triangle ABC. ABC are the sides of triangle ABC. Find angle C. These many students, these came in one of the mock. Many students thought that this is a very difficult question, but actually it's a very easy question. So if I check it out, this is nothing but D is B square minus 4AC. So these 24 square minus 4 into 7 into 25. D is less than 0. If D is less than 0, roots are imaginary. If D is less than 0, roots are imaginary. Imaginary roots always happen in pairs. Imaginary roots always happens in pairs. So A by 7 equivalent to B by 24 equivalent to C by 25. That means A is to B is to C is nothing but 7 is to 24 is to 25. 7 is to 24 is to 25. These 7, these 24, these 25. These 90 degrees. So these ACB. So angle C will be, it is forming a Pythagorean triplet. So what will be the answer? Angle C will be 90 degrees. Angle C will be 90 degrees. I hope it is clear. Idea clear. A is to B is to C is 7 is to 24 is to 25. Angle C will be 90 degrees because 7 is to 24 is to 25. It is nothing but a Pythagorean triplet. So 7 square plus 24 square equivalent to 25 square. 7 square plus 24 square plus 25 equivalent to 25 square. So another beautiful question. Ax square plus bx plus c and 7x square plus 24x plus 25 is equivalent to 0. Discriminant b square minus 4ac, d is less than 0. If d is less than 0, roots are imaginary. If the roots are imaginary, it will always happen in pairs. So if it happens in pairs, condition is a1 by a2 equivalent to b1 by b2 equivalent to c1 by c2. c1 by c2. I hope it is clear. Sixth question. This is the sixth question. Answer is 90 degrees. Suppose seventh one. Seventh one is a tough question. Question is f of x plus 1. F of x plus 1 is nothing but 7x square plus 6x plus 3. F of x minus 1. F of x minus 1 is how much? Options. 7x square plus 22x minus 19. 7x square minus 22x plus 19. 7x square plus 22x plus 19. 7x square minus 22x minus 19. Very good question, sir. F of x plus 1 is 7x square plus 6x plus 3. 7x square plus 6x plus 3. F of x minus 1. F of x minus 1 is, so traditional method, it takes 2 to 3 minutes to solve the problem. Traditional method, it takes 2 to 3 minutes to solve the problem. Now look at ANC method. Maximum 20 to 30 seconds it takes to solve the question if you have understood the question. So what I will do is I will take x equivalent to minus 1. If I take x equivalent to minus 1, this is nothing but f of minus 1 plus 1. It is 0. This is nothing but 7 into minus 1 square plus 6 into minus 1 plus 3. 7 plus 3, 10, 10 minus 6, 4. So f of 0 is 4. Similarly, put x equivalent to 1 in the question. F of 1 minus 1 is 0. F of c should be 0. So first option, 7 plus 22 minus 19. It is 10. Second option, 7 minus 22 plus 19. 26 minus 22, 4. Very, very easy question if you know the approach. Put x equivalent to minus 1 in the question. If I put x equivalent to minus 1 in the question, minus 1 plus 1 is 0. F of 0 is 4. Put x equivalent to 1. If I put x equivalent to 1, 1 minus 1 will become 0. 1 minus 1 will become 0. So f of 0 equivalent to 4. F of 0 equivalent to 4. I hope the idea is clear. These are all very, very easy questions. If you know the logic, you can answer it very, very fast. Very, very fast. I hope the idea is clear. Next one, seventh one. Answer is option 2. Answer is option 2. Answer is option 2. Seventh one, eighth one. F of m plus n. F of m plus n is f of mn. F of mn. Mn belongs to R. Mn belongs to R. F of 2 is 2005. F of 2 is 2005. F of 2 power 2005. F of 2 power 2005. Another good question. F of m plus n is f of mn. F of m plus n is f of mn. F of 2 is 2005. F of 2 power 2005. Another good question. Another good question. Suppose if I take m equivalent to 1, n equivalent to 1. This is nothing but f of 2 equivalent to f of 1. If I put m equivalent to 1, n equivalent to 2. This will become 1 plus 2 is 3. F of 3 equivalent to 1 into 2, 2. If I put m equivalent to 1, n equivalent to 3. 1 plus 3, it is 4. F of 3 equivalent to f of 4. 1 plus 3 is 4. F of 4 is 1 into 3. Now if you observe, starting from f of 1, if the functions are like this, f of 1, f of 2, f of 3, f of 4, this is equivalent to f of 1. This is equivalent to, all are coming back to f of 1 or f of 2. So f of 2 power 2005. F of 2 power 2005 is nothing but f of 2. F of 2 is nothing but 2005. Everything. The next value, f of 3 is becoming f of 2. F of 4 is becoming f of 3. F of 3 is becoming f of 2. This is a classic example of a constant function. This is a classic example of a constant function. This is a classic example of a constant function. What do you mean by a constant function? Singular output. Only one output. Constant function. Constant function. It is singular output. Singular output. F of 1, f of 2, f of 3, f of 4. F of 2 will be equivalent to f of 1. F of 3 will be equivalent to f of 2. F of 4 will be equivalent to f of 3. So if the function is f of m plus n is f of mn. F of 2 is 2005. If I substitute the values, f of 3 is becoming f of 2, f of 4 is becoming f of 3, and so on. And so on. I hope it is clear, right, sir? Idea is clear. Next, ninth question. Eighth question, I hope it is clear. Ninth question. Ninth one. Varieties of questions in our class. Ninth one. Another variety of question. F of x plus f of x. F of x plus f of x is x square minus 3x plus 5. F of x plus f of x is x square minus 3x plus 5. F of 1 is 2. F of 1 is 2. F of 34 is how much? F of 1 is 2. F of 34 is how much? F of x plus f of x is x square minus 3x plus 5. f of 1 is to f of 34 is. Another good question. Put x equivalent to 1 because we know f of 1. So f of 1 plus f of 1, it is nothing but 1 minus 3 plus 5. 6 minus 3 is 3. F of 1 is 2. 2 plus 1 is f of 3 is 3. Put x equivalent to 3 because we know f of 3. So this is nothing but f of 3 plus f of 3, which is nothing but 3 square minus 3 into 3 plus 5. 9 minus 9 cancel 5. So f of 3 is 3. 3 plus 3 is 6. F of 6 is 5. F of 6 is 5. Again take x equivalent to 6. This is nothing but f of 6 plus f of 6, which is 6 square minus 3 into 6 plus 5. 36 minus 18, 18. 18 plus 5, 23. F of 6 is 5. F of 11 is 23. F of 11 is 23. Again put x equivalent to 11. Beautiful question where the output will become the input for the next one. F of 11 plus f of 11. It is nothing but 11 square minus 3 into 11 plus 5. F of 11 is 23. So 23 plus 11 is 34. So f of 34 is 121 minus 33 plus 4. 121 minus 28, which is 93. Another good question. Output becomes the input. Output becomes the input. Output becomes the input. Output becomes the input. F of x plus f of x is x square minus 3x plus 5. X square minus 3x plus 5. F of x plus f of x is x square minus 3x plus 5. What is the root cause of the problem? Root cause. Output becomes the input. Output, whatever you are getting, that will become the input for the next question. Output becomes the input for the next question. We got x equivalent to 1. I got f of 3. So x equivalent to 3 is the input. I got f of 6. 6 is the input. I got f of 11. 11 is the input. 11 is the input. I hope it is clear. 9th one, I hope the concept is clear. 10th one. 10th one. 10th one. Output becomes the input. 10th question. 10th question. A1 equivalent to 1. An plus 1 minus 3an plus 2 is nothing but 1. First one. 3 power 99 minus 200. Second option. 3 power 99 plus 200. Third option. 3 power 100 minus 200 is given. An plus 1 minus 3n plus 1 minus 3an plus 2 equivalent to 4n. So if I put n equivalent to 1, a1 plus 1 is 2. a2 minus 3a1 plus 2 equivalent to 4. a2 minus 3. a1 is 1 plus 2 equivalent to 4. a2 is nothing but 5. Now if you see, all the options are of the form 3 power minus something. 3 power minus something. If you observe, a2 is nothing but 5. 5 can be written as 9 minus 4. So 3 square minus 2 into 2. So a2 is nothing but 3 square minus 2 into 2. So similarly, if a3 will be, if 2 is there, here I got 2, here I got 2. So the a3 will be 3 cube minus 2 into 3. Similarly, a100 will be 3 power 100 minus 2 into 100. So answer is 3 power 100 minus 200. 3 power 100 minus 200. I hope the idea is clear. I hope the idea is clear. It's a very, very easy question, right? If you understand the concept, you will get the problem. Just try to draw an analogy, you will get the answer. A1 is 1. An plus 1 minus 3an plus 2 is 4n. Substitute n equivalent to 1. So A2 minus 3A1 plus 2 is 4. A2 is 5. 5 is nothing but A2 is 5. 5 is nothing but 3 square minus 2 into 2. A cube is nothing but 3 cube minus 2 into 3. So A100 is nothing but 3 power 100 minus 100 into 2. So answer is nothing but 3 power 100 minus 200. Answer is nothing but 3 power 100 minus 200. I hope the logic is clear. I hope the logic is clear. 10th one. A100 is 3 power 100 minus 200. So 11th question. Once you understand, these are all very, very easy questions. 10th one. I hope the logic is clear. 11th question. 11th question. 11th question. 11th question is another very, very good question. F of x is nothing but 4 power x by 4 power x plus 2. 4 power x by 4 power x plus 2. So this is nothing but 1 by 1997 plus another good question plus 4 f of 1 by 1997, f of 2 by 1997 and so on up to f of 1996 by 1997. 1997. Now the best way to solve this question is, do not get worried about this kind of numerical values. 1 by 1997, 2 by 1997. So if I call it as y, this is y. The last one is nothing but 1 minus 1 by 1997. 1 minus 1 by 1997. So this is nothing but f of 1 minus y. If I call the first value as y, the last value will become 1 minus y. So what we'll do is, what is the question? F of x is nothing but 4 power x by 4 power x plus 2. So first and last, let us take f of y plus f of 1 minus y. You take any value, you will get the answer. You take any value, you will get the answer. Let us say y equivalent to 0. Let us say y equivalent to 0. If I say y equivalent to 0, so f of 0 is nothing but 4 power 0 by 4 power 0 plus 2. It is 1 minus 3. These also 1 is nothing but 4 by 4 plus 2. 4 by 6 is 2 by 3. So these is nothing but 1. That means f of y plus f of 1 minus y is 1. That is nothing but f of y plus f of 1 minus y is 1. First plus last it is 1. First plus last it is 1. So here it is 1. First and last. From 1 to 1 added 998 times. So what is the answer for this question? 998. And f of x is 4 power x by 4 power x plus 2. 1 by 1997, 2 by 1997 and so on up to 1996 by 1997. First and last. First and last. If I take first as y, the last will become 1 minus 1 by 1997. First is y. First is y. Last will become 1 minus y. First is y and last will become 1 minus y. F of y and it is f of 1 minus y. If I put say y equivalent to 0. If I put say y equivalent to 0. Anil sir, why did you take y equivalent to 0? You can take any value, Kanna. You can take any value. Just to get the calculation faster, I did y equivalent to 0. If I did y equivalent to 0, f of 0 plus f third and third last is 1. Total 996 terms are there. In 996 terms, and very good question. The number of prime factors. Yesterday when a student asked the similar questions, I am taking this question. Find the number of prime factors for. Find the number of prime factors for 27 followed by 5 zeros ending with 1. Find the number of prime factors for 27 followed by 5 zeros ending with 1. 27 followed by square whole cube plus 1 whole cube. A cube plus b cube is nothing but a plus b into a square minus ab plus b square. This is nothing but 300 plus 1 into 3 into 10 square whole square minus 3 into 10 square plus 1 square. 301 is nothing but 7 into 43 into, can I write this like this, a square minus ab plus b square. Can I write like this? Tell me whether I can write like this or not. 3 into 10 square plus 1 whole square. 3 into 10 square plus 1 whole square. 3 into 10 square whole square is a square plus 2ab. 2 into 3 into 10 square. 6 minus 9 minus 3 into 2 square, and it is plus 1. So it is 7 into 43. This is 300 plus 1. 301 whole square, and it is nothing but 30 whole square. Our answer. So this is nothing but 7 into 43. A square minus b square is 301 minus 30, 271. 301 plus 30, 231. All are prime numbers. So how many prime factors it has got? It has got total 4 prime factors. It has got total 4 prime factors. I hope the concept is clear. So for a bigger number, how to find out the number of prime factors? How to find out the number of prime factors? 27 followed by 5 zeros ending with 1. This is nothing but a cube plus b cube is a plus b into a square minus ab plus b square. A plus b into a square minus ab plus b square. So this is nothing but 3 into 10 square whole cube plus 1 cube. A cube plus b cube is a plus b into a square minus ab plus b square. So 301 is 7 into 43. So this can be written as 3 into 10 square plus 1 whole square minus 9 into 10 square. So this is 7 into 43. A square minus b square is 301 square minus 30 square. 7 into 43 into 271 into 331. So total there will be a 4 prime factors. Total there will be a 4 prime factors. Total there will be a 4 prime factors. I hope it is clear, right? Next one. Write down 12th question. 12th, I hope it is clear. Right after the class, ensure that you revisit the class as many times as possible. 12th one. 13th question. 13th question. Greatest integer of x by 2 plus greatest integer of x by 3 plus greatest integer of x by 5. It is nothing but 31x by 30. 31x by 30. 0 less than x less than 1000. 0 less than x less than 1000. How many values x can take? X by 2 plus x by 3 plus x by 5, which is 31x by 30. 0 less than x less than 1000. How many values x can take? First, this is nothing but a greatest integer function. 3.9 is 3. Greatest integer of 3.1 also it is 3. Greatest integer. This is a greatest integer function. Greatest integer function. Greatest integer function. This is nothing but greatest integer. Greatest integer less than or equivalent to x. It is nothing but greatest integer. It is nothing but greatest integer less than or equivalent to x. This is nothing but greatest integer less than or equivalent to x. Greatest integer always gives an output. Greatest integer always gives an output an integer value. Greatest integer always gives an output integer value. Greatest integer always gives an output integer value. This is an integer. This is an integer. This is an integer. Integer plus integer plus integer. Left hand side is an integer. If left hand side has an integer, this 31x by 30, x should be a multiple of 30. X should be a multiple of 30. X should be a multiple of 30. How many multiples of 30 are there till 1000? 333. What is the answer? 333. So 1000 divided by 30 is nothing but 33. So answer is 33. Greatest integer function 3.9 is 3. 3.1 is also 3. Greatest integer function output is always an integer. So left hand side, first one integer, second one integer, third one integer. First integer, second integer, third integer. So left hand side will be an integer. If the left hand side is an integer, right hand side should also be an integer. Third question, I hope it is clear. Left hand side an integer, right hand side should also be an integer. Next, find the value for greatest integer of root 1, greatest integer of root 2, greatest integer of root 3, and it goes on up to greatest integer of root 50. Find the value for greatest integer of root 1 plus greatest integer of root 2 plus greatest integer of root 3 and so on up to greatest integer of root 50. Root 1 value is 1. So root 2 it is 1.414. Root 3 it is 1.732. So first three, root 1, root 2, root 3, greatest integer function always will give you 1. Root 4, root 5 till root 8. There are 4, 5, 6, 7, 8. 5 values. This will give you greatest integer 2. Root 9 to till the next perfect square. Root 15. It will give you 7 into 3. Root 9 is 3. Root 10 is 3 point something. Root 11 is 3 point something. Root 16 to root 24. That will give you 9 into 4. Similarly, root 25 into root 35. Root 36 is 6. So it is 11 into 5. Similarly, root 36 into root 48, which is 13 into 6. These are nothing but root 49 and root 50. Both will give you 7. So into 7. Answer is addition of all this. I hope it is clear. Greatest integer function. Greatest integer less than or equivalent to x. Root 1 is 1. Root 2 is 1.414. So lowest value is 1. Root 3 is 1.732. Lowest is 1. For the first three values it is 1. So it is 1 into 3. 1, 1, 1. So I hope it is clear, right? Next one. It is 2 into 5. 3 into 7. So the pattern is like this. It is 1 into 3. Next it is 2 into 5. Next it is 3 into 7. Next it is 4 into 9. Next it is 5 into 11. Next it is, if you observe, it is 6 into 13. Next two values 2 into 7. Add all the values. Whatever the answer that you get it, that itself is the answer. Add all the values. That itself a resultant is the answer. I hope it is clear, right? 14th one. I hope it is clear. 15th one. We'll keep solving some good varieties of questions in our class so that you'll understand the kind of questions that are being asked. Next one. 14th one. I hope it is clear. 15th question. Please take the 15th question. 15th one. Which of the following is greatest? 2 power 1 by 20, 3 power 1 by 30, 4 power 1 by 40. So if I see this, take the LCM of the denominators in the powers. LCM of 20, 30, 40, which is nothing but 120. So these are nothing but 2 power 6 power 1 by 120. These are nothing but 3 power 4 power 1 by 120. These are nothing but 4 cube power 1 by 120. 64 power 120. 81 power 120. 4 cube is 64. 64 power 120. Which is greatest? This one is greatest. So answer for this question is 3 power 1/3. Root of x is 25. How many integral values x can take? How many integral values x can take? What is this bracket? Bracket is nothing but greatest integer function. Just now we discussed the similar model, so we'll solve the same question. Greatest integer function of root x is 25. How many integral values x can take? How many integral values x can take? So root of 625. Root of 625 is 25. Next value is root of 676 is 26. So till here I will get 25. Till here I will get 25. So how many values? How many natural numbers are there from a to b? b minus a plus 1. 6 minus a plus 1. 676 minus 625 is 51. 51 plus 1 is total integral values it can take is 52. Total integral values it can take is 52. Sorry sir, it is 51. 50 plus 1, 51. From 625 to 675 it will take 25 point something. Root of 676 is 26 point something. So highest minus lowest plus 1. Highest minus lowest plus 1. 675 minus 625, 50 plus 1. So it is 50. Highest minus lowest plus 1. Highest minus lowest plus 1. Highest minus lowest plus 1. I hope the idea is clear.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for